Hello, beautiful people, and welcome. We are continuing our review for our sequences in series assessment. Now, this video is part 3. So if you missed part 1 and part 2, go ahead and go back to those videos and watch those. As a disclaimer, I am human, so if I make a mistake, please let me know where the mistake happened so that way I can learn and we both can learn from it and I can fix it and make the video better. Now, also, disclaimer, if you hear a loud bell, I apologize in advance. We are on campus. Also, if there's an intercom, I apologize in advance for any loud noises. We are on campus, so that can happen. All right, so in part 3, we're going to continue with number 19. Number 19 is asking us to determine the number of terms in each arithmetic arithmetic series. Now, I did do this a little bit earlier, and the video did not save, so I'm going to try to do this again. So for our formula, and this is the sum of a finite arithmetic series. Our formula is as such. A sub n is equal to n divided by 2 times a sub 1 plus a sub n. That's the formula that you're going to need for a finite arithmetic series. Just to remind you what each little part is, a sub 1 is our first term. A sub n is our nth term. Let's see if I can hide some of the work that I did for a little bit. N is the number of terms. And then one last bit. Oh, I think that's it. That's all we need. And then S sub n is the sum. Okay. All right. So if you're using the summation notation and you are not starting with a sub 1, you're starting with like a sub 3, you need to take your upper minus your lower plus 1 in order to find what your term, what your number of terms are, okay? So you need to make sure to do that. If you're starting with a sub 1, that's okay. Whatever your nth term is, that would be your n value. All right, so let's go ahead. So here's our formula. I'm going to rewrite it again. So we know some things. I'm just going to go ahead and show you, and we'll walk through it. N is what we're trying to find. In number 19, it's asking you to determine the number of terms. So we need to find out what N is. A sub 1, they give us that information. A sub 1 is 26. A sub N is 116. And they give us S sub N. Okay. So let's go ahead and solve for the quantity of term numbers. So we know that the term is 166, but we don't know what position that term is in. So that's what we're needing to find. Start out with your formula, plug in or substitute in your values, your given values. So we have here. After this, you're going to add 26 plus 166. That gives you 192. Go ahead and divide. This is 192 divided by 2, so that way you can get rid of that fraction. So that gives you 96. So you have n times 96. Divide that both sides by 96 to get your variable by itself, your n. Therefore, n is 15. Okay. Once again, plug in your values, simplify, keep simplifying, get your variable by itself by dividing, and therefore you have your n. This is very similar to number 20. Number 20 is, again, giving you a sub 1, it's giving you a sub n, and it's giving you s sub n. So, and this is a comma, not a dot. So this is 11,525. Again, here's your formula. Substitute or plug in your given values. Simplify, keep simplifying. So here you're adding 451 plus 10, that's 456. Divide if you can, but since 461 is odd, you can't evenly divide by 2. So what I did instead is n divided by 2 is attached to 461 by multiplication. So I undid multiplication by dividing by 461 both sides. 11,525 divided by 461 is 25. Then I have n divided by 2 left over. Since I have n divided by 2, I multiplied both sides by 2. 25 times 2 is 50. So my n is 50. That means a sub 50 is 451. So 451 is in the 50th position. All right, let's move on to number 21. Let me actually take a moment to write the answers down for number 19 and number 20. So number 19, n was 15. Number 20, n was 50. All right, so moving on to number 21, evaluate each geometric series. Okay, now it's super important that we pay attention what type of series is given. For example, arithmetic has its set of formulas, geometric has its set of formulas. So since we're given the geometric series, we're going to play around with two different formulas. So if the series is finite, that means we know what the last term is, so we know when to stop adding them up. So if we know that if we know that the geometric series is finite, we're going to use the following formula. S sub n is equal to a sub 1 times 1 minus r to the n power, all divided by 1 minus r. That is our formula. So let's get started with number 21. Number 21, don't worry that it says dot, 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 because you know what the last term is. Last term is going to be 6. So we can stop, we basically know when it terms, when the last term is. Okay, so let's use the given information. So which number one? 21. 21 is telling us -3 plus 15 minus 75 plus 375. This continues until, excuse me, I don't know if you heard that. That was my phone. Let me silence that. Sorry about that. Okay. So we know that it's going to, the last term that we're going to add to it is going to be in position number 6. Okay, so what do we need? We first need to identify what our first term is. We also need to identify what our common ratio is. And we already know what it is. It gives us that value. Our first term is -3. So how do we find our common ratio? Is you take your previous term, or you take your right term divided by your left. Right term is 15. Left term is 3. And again, you have to double check and make sure this pattern holds. Why it's called a common ratio is because the ratio is common and you have to continue that pattern. So if it doesn't continue, if that pattern changes, then it's no longer common and you do not have a common ratio. So 15 divided by -3 is -5. And I'm going to double check. So -3 times -5 is 15. 15 times 5 is 75, but we have a negative here. And then I'm assuming this works as well. All right, so let's use our formula. S sub n is equal to a sub 1 times 1 minus r to the n power divided by 1 minus r. So we have a sub 1 is -3 times 1 minus r is -5 to the nth power, in this case it's 6, divided by 1 minus -5. Now I can't stress enough how important negatives are here. Super duper important. PEMDAS is super duper important. Make sure you know your order of operations. Do not combine these first unless you take care of your exponent, okay? Take care of your exponent, then deal with everything else. Okay, so let's see. negative 3 times 1 minus, and let's see here. I have no idea what 5 to the 6th power, what negative 5 to the 6th power is, so my calculator is going to have to help me on that. And when you're typing it into your calculator, you have to type in, let me show you. You have to type in negative 5 inside of parentheses. If you do it the other way, your calculator will assume that negative is a negative 1 being multiplied after you have raised it to that power. So negative 5 to the 6th power is a big number. It is 15,625. That's all divided by 1 plus 5. And now I know it's 1 plus 5, so we'll simplify that in just a little bit. So negative 3 times, now this is where you can just start typing things into your calculator and letting the calculator do the work for you. But I'm going to do this step by step. So 1 minus 15,625 is negative 15,624. All of that's being divided by 6. So we're taking negative 15,624. We're multiplying that by negative 3 and dividing that by 6. So S sub 6, we know that n is 6, is equal to 7,812. So given this sequence, when I add all of that up, the sum of the series will be 7,812. Right, let's do the same thing for the following questions. Okay, number 22. Again, it's giving us a series 1 plus 5 plus 25 plus 125, dot, dot, dot. When we know n is 8, we know that it is finite. So then we have a sub 1 is 1, a sub n. Do we need a sub n? We don't need a sub n. I shouldn't have written that down. Okay, sorry about that. We need r, common ratio, and we know that n is 8. Common ratio again is what happens from 1 to 5, from 5 to 25, from 25 to 125. And so you don't have to do what we did in number 21 is to divide. If you can see the pattern, just go with it. So I'm going to multiply by 5 each time. So our common ratio is 5. Rewriting the formula, S sub n is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. So then I know that S sub 8 is equal to a sub 1 is 1 times 1 minus r. We know r is 5 to the 8th power, all divided by 1 minus 5. So I'm going to get rid of this. Oh, you can't see. Sorry about that. I'm going to get rid of this 1 because anything times 1 is whatever. So 1 minus 5 to the 8th power divided by negative 4. Okay, and I'm typing into my calculator. Again, this is different than the question before. So do you notice how my parenthesis is only around the 5? So this is 5 to the 8th power, not negative 5 to the 8th power. So I have 1 minus 390,625, big number, all divided by negative 4. So I'm going to do 1 minus 390,625. And I'm going to divide that number by negative 4. S sub 8 is 97,656. Now from here to here, I typed it into my calculator instead of writing everything out because we're dealing with larger numbers now. So I'm letting the calculator do the hard work. All right, let's move on. Number 23, I'm going to flip over my page. let me take a moment to, where am I? There we are. So number 21, the answer for that was S sub 6 is equal to 7,812. For number 22, S sub 8 was equal to 97,656. Excuse me. All right, so number 23 is using summation notation. So it is using the Greek capital letter sigma. And let's talk about that. Okay. So when you have sigma, here's your sigma. The top number, in this case 9, is your upper limit. So that means your series ends with this number. Now the bottom number, this is your lower limit. That means your series begins with, and I'm saying n, we're just using the same letter here. So in this case, it's using I, but we're more familiar with using n. Okay, now the inside in this case, -2 times 1/5 I minus 1, the inside, let me put that in a bubble so that way it can be separated. This is the explicit formula. Rule, formula. So in order to find out what everything is, we still need our information. Here's our formula. S sub n is equal to a sub 1, 1 minus r to the n. Now again, we know what the last term is because we know what the position, right? The last term is in the 9th position. So we know that it ends there, it's finite. So we use the finite formula. So in our finite formula, we need a sub 1, we need r, and we need n. So if you recall earlier in numbers 19 and 20, n is your term. So it's like the number of terms, the quantity of terms, or the number of terms. Let me write number of terms, because that could be misleading. So the number of terms you're actually adding together. So this right here is you take your, if you recall, take your upper limit minus your lower, add 1, and that's what you're going to get for n. Your r, you need to figure out r from your formula. So if we rewrite the formula, the explicit rule, the explicit formula, let me move this aside. We have -2 times 1/5 I minus 1. So if you recall the formula, a sub n is equal to a sub 1 times r to the n minus 1. That means r, in this case, is 1/5. A sub 1 is equal to -2. So again, so this is our formula. In this case, it'd be a sub I because we need to have our variables matched. So again, this is a sub 1 times r to the I minus 1. So we have that information. All right, since we have that information, we can start determining or evaluating the geometric series. So S sub 9. So in order to find out n, We take the upper minus the lower plus 1. So n is equal to the upper minus the lower plus 1. So n is 9. Now you need this rule when you're not starting with the first term. Let's say if you're starting with the third term, then that comes in handy. But if you're starting with the first term here, then it's the n is always going to be the top, the upper limit. But that's only if you're starting with 1 as your lower limit. So s sub 9 is equal to a sub 1 is negative 2 times 1 minus r is 1/5 to the 9th power. 1 minus r, and r is again 1/5. S sub 9 is equal to, typing it in our calculators, make sure you're using parentheses. So 1/5 to the 9th power. We're taking that number. Let's see. I'm going to try to do this, -2. I'm going to type all of it into my calculator to see if that gives me what I need. Give me just a second. Sorry about the awkward silence. But let's see if that gives me what I need. We are on what number are we on? We are on number 23. I'm just doing really quickly, I'm typing exactly this into my calculator and seeing if that gives me what I need. Yep, and it actually did. So typing it into your calculator all at once is fine. So let me show you how to do that. So what I'm doing here, and you can barely see that. Let me shift it. Okay, so I'm typing -2 times 1 minus, again, just like I have written it on the paper, I'm typing it in on the calculator. So -2 times 1 minus 1/5. And then how to do fractions on a calculator, you divide it. So 1 divided by 5, that is 1/5. And close that parentheses, raise that to the 9th power, and then close that parentheses. I'm going to press enter. Then I'm going to say divided by 1 minus, again, just like I have written on the sheet of paper, 1 minus, parenthesis, 1/5. And then what I did here on the bottom is I put all of this in parentheses, so I know that my numerator is divided by all of this denominator. The calculator needs to be told what to do. It can't assume things, or it will, and make it wrong. Okay, enter. So then S sub 9 is equal to -2.49999, or I'm going to round it to 2.50. So 2.4999. So S sub 9, let me move the calculator away so we can see. S sub 9 is about -2.50. Okay. Moving on to number 24. Number 24. Number 4, we have our upper limit being 7, our lower limit is 1, and our explicit rule or formula is given as well. Again, we need to identify a sub 1, we need to identify r, and we need to identify n. If your lower limit is 1, n is going to be 7. Your upper limit, so if your lower limit is 1, your upper limit, it will be n. R comes from your explicit, and a sub 1 comes from your explicit. So a sub 1 is 2, r is negative 6. Rewrite your formula for the finite geometric series. So we have a sub 7 is equal to 2 times 1 minus negative 6 to the 7th power, all divided by 1 minus negative 6 to the 7th power. So we have 2 times 1 minus negative 6 to the 7th power, all divided by, oh, this is wrong. This should not be to the 7th power. This is just 1 minus negative 6, which is 7. Two negatives make a positive. Now don't do that same mistake here. Don't combine these. You have to take negative 6 to the 7th power first before doing anything with that 1 minus. All right, again, I'm going to try to cheat a little bit and save some time by plugging everything into my calculator all at once. So I'm saying 2 times parenthesis 1 minus parenthesis negative 6 parenthesis to the 7th power parenthesis equals, taking that number, writing it down just in case, dividing that by 7, and it gives me S sub 7 is equal to 79,982. Okay. Moving on to number 25. Let me take a moment to write down my answers on my actual worksheet. Okay, so 23 was S sub 9 is equal to negative 2.50-ish. And 24 S sub 7 is equal to 79,982. Now in number 25, you're going to notice something, that when you look at your upper limit, it is infinity. So that means that your geometric series is infinite. So, okay, so that changes everything. Okay, that changes everything. So the first thing you need to do when you're dealing with infinite geometric series, I'm gonna is you need to know the formula, but you also need to know when the limit diverges and when it converges. Okay, I'm gonna get a separate sheet of paper here. So let's talk about the formula here for a little bit before we continue. Okay, so the infinite geometric series formula is S sub n is equal to a sub 1 all over 1 minus r when the absolute value of our common ratio is less than 1. So if, here's our thinking bubble, if the absolute value of r is greater or equal to 1, it does not have a sum. It's called diverges. So diverges, this means does not have a sum. So if it is less than 1, the absolute value of our common ratio is less than 1, then it converges. It does have a sum and we can do it. So that's super important, because if it diverges, then we don't do anything. We just say it diverges, it does not have a sum, and we move on with our life. But if it converges, if the absolute value of r is less than 1, then we actually need to proceed and find what the sum is. Okay, let's start with number 25. So the summation of 108 times negative 4/3 to the m minus 1 from m equals 1 to infinity. And so again, this is the explicit, so therefore this is a sub 1. This is r. So am I having to check? Absolutely, I have to check. So check for r. Check, I can spell. So absolute value of negative 4/3 is equal to 4/3. And 4/3 is in fact greater or equal to 1. This is 1 1/3, so it is bigger than 1. Therefore, it diverges and it does not have a sum. So for like number 25, what's the answer? You can say diverges does not have a sum. So answer, no sum. It diverges. Okay, let's try number 26, see if that gives us better luck. 26. So again, the sum of negative 2 times 1/2 to the n minus 1 as n is equal to 1 approaching infinity. So then again, this is a sub 1, this is r. The absolute value of 1/2 is 1/2, which is less than 1. We are happy. That means it converges. So then we use our formula, S sub n is equal to a sub 1 divided by 1 minus r. S sub n, S sub So S sub n is equal to a sub 1, is negative 2. 1 minus r is 1/2. So I have negative 2 divided by 1/2. So it should give me negative 4. And again, sometimes I don't trust myself, so let's do this on the calculator. Negative 2 divided by 1/2 is in fact negative 4. So it converges to negative 4. Okay, let's try again with number 27. Number 27. And actually, before we continue on number 27, let me pause the video. We're going to continue this in part 4. That way each video is not too long for you guys. All right, go ahead and continue in part 4. Thank you for watching.